Okay, in this series of videos, we are going to be finding the roots for each quadratic expression. Specifically, we want to state the method we used and why. So what I really want to focus on today is picking a method and why that's the best method. So personally, I always start with, can it be factored? So I'm going to look at question 1. In question 1, I have -4 here. Are there factors of -4 that are going to add up to 3? So if I put a little -4 here, well, I have 1 and 4. Oh, because it's negative, one of these has to be negative. If I made 1 negative, this would add to 3. So for me, the best method would be factoring because it's simplest. Add 2, 3. So I'm going to break this up, and I'm going to have an x plus 4, x minus 1. I tend to put my larger number here because this sign will always follow my larger number. So now I take each of those and I set them equal to 0. Excuse me. And then x equals 1. Now I like to double check myself just to make sure I'm correct. And so I'm going to plug in -4 squared. I'm just plugging it in for my x's, plus 3 times -4 minus 4. And that equals 0. So I know that one's correct. And then I'll just plug in 1. And that equals 0. So I've checked my work. These are my zeros, and factoring would be the best method for that. Okay, so in question 2, again, the first thing I'm going to look for is, can I factor this? Well, one thing that I notice right away is that I have a plus sign here. There's no way that I can multiply two numbers that are going to add to 16 and give me a 0 middle term. What I do recognize, though, is that I only have one term that has x in it. So I should isolate my x. So I'm going to set it equal to 0 again. I'll move the 16 over there. I'll divide by 4 because I'm trying to get x by itself. And then I'll take the square root of both sides. Well, the square root of x is just x squared is just x. And the square root of -4, well, as soon as I'm taking a square root, it's going to be plus and minus. The square root of 4 is 2, but because of that negative sign, there's going to be an I in there. So x equals plus or minus the square root, plus or minus 2i. And the method I used was the square root property. And I did that because there was only one x term. Okay. So this question's a little bit trickier. One thing that I see is I have a prime number here and a prime number here. So I could try factoring it and see if it works. If I'm worried that factoring is not going to work, I could either complete the square, do the quadratic formula. I always like to factor first, and so since I have a prime here and here, let's try factoring. So since this is a prime number, this is going to have to be 2x, and this is going to have to be x. Now, -5, one of these is going to be 1, and one is going to be 5. So I'm going to just start with here and here and see how this works. So if I multiply those, that's going to give me x. If I multiply those, I get 10x. Is there any way that I can subtract these to get -9? Oh, I can make that a negative and that a positive. Now when I add those, it's going to give me the -9 in there. So factoring works. So I'm going to say factoring. And really what I did was I did guess and check. Again, if this isn't the method that you chose, that's fine. You could do this by completing the square. You could do this by the quadratic formula. You could do factor by grouping. You could do any of those. So I haven't got my answers yet. I need to set each of these equal to 0 and solve. So I subtract 1. I get 2x equals -1, divide by 2. And so I have x equals -1/2. And then this one is x equals 5. Again, I just like to double check my answers. Generally, if one of these is correct, they're both correct. So I'm going to put in 2 times negative 0.5 squared minus 9 times negative 0.5, and then minus 5. And I got 0. So I know I did it correctly. Okay, so for question 5, the very first thing that I notice is this is a perfect square. This is a perfect square, and it's broken up with a minus sign. So I'm going to factor this using difference of squares. So when you do difference of squares, your 2 sets of parentheses have to be exactly the same, except one's going to have a plus sign and one's going to have a minus sign. So if these are exactly the same thing, what times itself gives us 3x squared? 3x. 3x times 3x gives us 9x squared. What times itself gives us negative 49? 7 and 7. So I have factored that. I'm going to set each one of them equal to 0 and solve. And then divide by 3. So x equals, and I know this is going to be the same thing, but it's going to be the positive. 7/3. You can always check your work. So I'm going to do 9 times 7 divided by 3 squared minus 49. I get 0. And you could do it again with the negative. Normally, if you have one of them right, you have both of them right. But just to be cautious, you can do both. There we go. Okay, so for question 6, we could do quadratic formula. You could do completing the square, because those are going to work every single time. But I notice a prime number here and a prime number here. So I'm going to try factoring. Now, because this is a prime number, I would have to start with 3x here and x here, because 3x times x is the only thing that's going to be 3x squared. 7 is also a prime number, which means that these have to be 1 and 7 somehow. I'm just going to try by plugging in a 1 there and a 7 here. Now if I multiply that, that's x. If I multiply that, that's 21x. Is there any way I can add these and get negative 22? Oh, if I make both of these a negative, I can. So now I'm going to set these equal to 0 and solve. And so I'm going to get x equals 1/3 and x equals 7. So the method I used here was factoring. And again, you could use completing the square or the quadratic formula, but that was fastest for me. Okay, so we are looking at question 7, x squared plus 5x. What do I do here? Oh, well, I noticed that both of these have an x. So why don't I pull out my greatest common factor? I pulled an x out because if I distribute this back in, x times x is x squared, and x times 5 is 5x. So I haven't changed this at all. Well, I have two factors. The zero product property tells me that if I set each of these equal to 0, then the whole thing's going to equal 0. So I'm going to set x equal to 0, which is just 0, and I'll set x plus 5 equal to 0, which is going to be x equals negative 5. So my answer is x equals negative 5 and 0. So my method here was greatest common factor factoring. And I chose that because I could see that they had a greatest common factor. Now let's just double check our answer and make sure it's correct. I feel a little silly plugging this one in. I'm going to plug 0 in, but I know that 0 squared plus 5 times 0 has to be 0. Now let's plug in negative 5. Remember, when you plug a negative in, put it in the parentheses. Negative 5 squared plus 5 times negative 5. And I get 0 again. So I know that I solved it correctly. Okay, in this problem, number 8, I have x squared minus 7x plus 30. I always check to see if I can factor first. And so I want to see, are there factors of 30 that are going to add up to negative 7? So my factors of 30 are 1 and 30. That doesn't add up to negative 7. 2 and 15. That doesn't add up to 7. 3 and 10. Oh! Could that add up to -7? Well, both of my signs have to be the same. Well, that doesn't work. That adds up to -13. Just kidding. And 4 doesn't have any factors. 5 and 6. Nope. And that's it. So factoring is not going to work. This is not factorable. So let's do the quadratic formula. Identify a, b, and c. A is the coefficient in front of our x squared term, and it's a ninja because we can't see it. So we have 1. B is -7, and c is 30. So I'm going to plug this into my quadratic formula. -b plus or minus the square root of b squared minus 4ac over 2a. So I have 7 plus or minus. You can say thank Miss Seidel for the choir over here. The square root. 7 squared is 49 minus 4 times 1 times 30 all over 2 times 1 is 2. Now remember, you always want to figure out what your discriminant is first. I probably don't need to put this in my calculator, but I'm going to. 49 minus 4 times 1 times 30. Oh no, I forgot a parenthesis. Don't worry, we got it, guys. -71. Okay, I need to see if I can simplify this. So can 71 be divided by a perfect square? I don't think it can, but let's try it anyway. I already know that that one's not. So this is not going to be able to get broken down anymore, but that negative means it has an I. So our final answer is going to be x equals 7 plus or minus the square root of 71. I goes on the outside, and remember I is bold, all over 2. And there's our final answer.